And here we are doing this on a Friday again. I may as well just rename this place Pi Day Friday, huh? Because it's going to be on next Friday too, not next Thursday. But whatever day it is, where you are, no matter what time it is, good morning, good afternoon, good evening, wherever you are in the world, you have found ADRAMADA. I might look and sound a little bit differently this week. We've changed the tech around to accommodate today's show. We have an amazing guest on, Maxine Hayes, who's going to talk with us a little bit about an operating system called Plan 9. And what a knockout, what an amazing operating system. All right, I won't get ahead of myself just quite yet. So it is Andromeda, another Dave Rush Ask Me Anything digital alchemy. I am the aforementioned Dave Rush. And come for the shirt, stay for the news or the project or the interview or whatever. We're devoted to collecting and disseminating information on technology because we love it. If you're not watching this live, you can find out now that we recorded this on Friday, February 7th, 2025. What a good year. Just fun to say. And it's nicely divisible by all kinds of good numbers. 7 p.m. Central Time, and that matters because right now we're on Central Standard Time. Excuse me. In 2 days, we're going to change to Central Daylight Saving Time. Saving is singular, if you ever needed to know that. It will still be at 7 o'clock Central Time. It's 7 Central. So if you are watching this from a place that does not participate in a time change at this time of year, this show will be, the live show will be an hour later for you. So we fall back. That means you can stay at the bar an extra hour on Sunday night. The bar's not open on Sunday night. Okay, drink later at home. Today being, what is this? March 7th, yeah. Noteworthy in history. I didn't have any history last week, but I was looking over the stuff this week, and I found a few. So we're going to extend just a little bit here. On this date, in the year 321, this matters to most of us, Roman Emperor Constantine I decreed that the Dies Solis Invicti, also known as Sunday, is hereinafter the day of rest in the Roman Empire. And that spread to a large part of the world, except for some parts of the Middle East, who were usually shifting things a day early. On this date, March 7th of 1774, I like this story. Everybody in America knows the story of the Boston Tea Party. They were upset that we were being taxed on tea that was coming from the U.S. and going to Britain and then coming back, and they had to pay taxes on it, and it was a tax protest. So they threw the Tea Party, they threw a bunch of tea in Boston Harbor. Well, nobody knows the rest of the story, and frankly, I didn't either until I ran into this week when I was doing updates. King Charles III charged all of the colonists of Boston with attempting to injure British commerce. And this led to him closing Boston port to punish the colonists for the Tea Party. So there's going to be a much longer story about that, and I am so intrigued, I'm going to be looking it up. On this date, in 1876, Alexander Graham Bell received a patent for the telephone in the U.S. There is, of course, historical revisionists who say he didn't invent it or he didn't invent it first. I don't care. He got the patent in 76, and we're still using his tech today. And finally, last news of the week, within my lifetime, and stuff that I'm interested in, on this date, 1975, RCA Records releases Young Americans from David Bowie's 9th studio album, recorded in Philadelphia, Pennsylvania, and New York City, with appearances by John Lennon on 2 tracks. Peaked in the U.S., charts at number 9 as an album, and number 2 in the U.K. Okay, that's news. What else? I put at the beginning of the chat session, before we started the show, contact information and our Discord server invite and how to find me on X and all that good stuff. If you ever want to contact with me, or see some of our platforms and participate on them, that's where you find that info. Last week's show completed our 4-part series on subnetting. Mostly went well enough that I'm not going to do a re-record of a whole new course. I've downloaded all of those, and I will start editing them next week into a series of course. And I don't know how this is going to go. I want to offer it as a free course on Udemy, and I was reviewing the requirements for that. It's got to be under 2 hours. And we are sitting at about 2 hours and 20 minutes right now. So I'm going to see if I can hack out 2 hours or 20 minutes of that. I'm sure I can, as long as I can still make it make sense. You know, I get very redundant on these kinds of things. And I'm fixing, of course, the typoed slides and all that good stuff. So sometime in the next week or two, we should have our first Udemy course up. And if I can't do it as a freebie, it'll be up there for the cheapest that they allow, $5, $10, whatever that's going to be. So we're going to put a course on Udemy. And if for some reason I can't put it up there, I will post it to ADRAMADA.com. All right. A couple quickies here. And so today we're bringing our special guest, Maxine Hayes. I'll give you her background. She'll give you her background. And she's going to talk about something that she has some expertise in, done significant research, done a marvelous paper on it. It's an operating system called Plan 9 from the original. They paid an homage to the old B horror movie, Plan 9 from Outer Space. I love that movie. It's one of Bela Lugosi's first movie, and you guys know I love B horror movies no matter how. It's just an awful film. As far as production and directing goes, it's just awful, but it is a true classic. And do you want to do this? Yeah, I didn't do this background. I wasn't going to ask Maxine to do this. This operating system was created by the people who invented UNIX and C and awk and tons of other things. And I won't even mention any names, because to mention one name is to I need to mention them all, and I will surely leave somebody out. So an amazing development team over at Bell Labs in the 60s and 70s, 60s. So they invented UNIX, and they worked on it to the point that it met its assigned goals. But they weren't happy. They said, we have this concept in mind that can take it so much further. So the team on their own created Super UNIX, and it didn't get called UNIX. And in fact, the only thing that it has in connection with UNIX is its roots. But Plan 9 is an entirely different operating system. Its architecture is amazingly different. Runs on a lot of different platforms, and Maxine's going to talk about that with us. I've done some research. It runs on Pi. In fact, the first port of it was done in 2012. I read this paper. I'm totally captivated. I asked Maxine a couple weeks ago, 6 weeks ago, if she would come on the show and share her insights, and very graciously accepted our offer. So we will have her on in the next 5 to 7 minutes. I'm going to get through a little bit of stuff. This week, next week, Friday the 14th, which is March 14th, which we all know is 3/14 Pi Day. So I'm doing the show on Friday next week. I don't have a gig. I could have done it on Thursday, but since we've got the date, we got to do something about it. So we'll do some Pi-oriented project. I don't know what it's going to be, but I'll make it fun. All right, let's do news of the week. I have so many programs running now that I can't keep track of them all. Yeah, okay, then you go here and slide this there. There we go, we're ready to do this. All right, I'm only going to do 5 pieces of news this week. 3 of them, space, maybe 4 of them, depending on how we look at it. Space is hard. It's not impossible, but it's hard. So there were a number of major space-oriented things this week. Blue Ghost, March 1st, Sunday, this past Sunday, landed successfully on the moon. You can see on our slide there's a picture of its shadow, and that's Earth beyond it. And it's working for a living. It was a good landing, all intact. It's in good position to operate. It did research on the way up. It's doing research there. It's a 2-week mission, 10 scientific payloads, and I think like 40 actual experiments with all that stuff. So it's good stuff. Next 2 weeks, we'll keep an eye on it. They have already downlinked more than 27 gigs of data. That was before the landing. Did some signal tracking from the Global Navigation Satellite System, not GPS, but GNSS. They did some testing and some measurements going through the Van Allen radiation belts and lots more. I'll dump that. Next. Then came the Athena lunar lander, which landed 2 days ago with a couple of problems. Okay, a lot of problems. It's a commercial operation partnered with NASA and other organizations. The company is Intuitive Machines. The name of the lander, I just put that together today, is Athena. Athena was the goddess of the hunt and the goddess of love, and oh yeah, she's the goddess of the moon. So, okay. It landed safely, landed intact. However, it fell over on its side, but worse than that, it landed over 200 meters off of its target, put it in a crater that, with it on its side, will not allow the solar panels to collect any solar energy that's measurable. And 2 days after it landed, today, this morning, they announced that the mission is over. There's no solar sunlight to recharge the batteries. The mission is ended. And so space is hard. Space continues to be hard for the nice folks over at SpaceX. Test rocket yesterday broke up on ascent. We're watching the video of it, and they kind of followed it real time. We appear to be losing attitudinal control, and I just saw some of the engines shut off, and then they shut down, and then a little while later, we got to see all this debris crashing through over the Caribbean Sea, Caribbean if you prefer. And that was Starship. That's their biggest boat out there. And one more, SphereX. Today is the 7th. That means tomorrow, the 8th, this is going to launch. It's a 2-year astronomical satellite that is going to chase down data on more than 450 million galaxies and more than 100 million stars in our own Milky Way. Every 6 months, it's going to do a grand sky search, and then it's going to narrow into a whole bunch of other searches. Nothing visual. It's all radio frequency and infrared. So another fun one to watch. And then the last thing I've got, I was working on computer stuff all week as I do, and I realized that I got to update this program. Oh, wait, I haven't updated that program. And next thing I know, it's update day, and I thought that'd be a good idea to remind everybody to do your updates. Everybody's got their own favorite proprietary little programs, and I updated some of those. I also had to update Office 365 on several computers, LibreOffice on at least 3 computers, 1, 2, 3, 4. Windows 11 on my 2 Windows 11 boxes, all my Ubuntu boxes, and I thought I would check. I haven't burned a Raspberry Pi image in a while, but my Raspberry Pi imager was out of date, so updated that. And that completes the news of the week. We do this, and at this time, if you're on, Maxine Hayes, would you fire up your camera and join us? And if you're not, I will do interpretive dance with sock puppets. Hey, you're there.
Good
Maxine
evening.
Hayes, how nice to see you.
Very nice to see you.
Oh, and thanks for coming on the show. You are beyond an amazing person. People with your credentials, your expertise, your knowledge, your drive, I typically ascribe to people in their 30s, 40s, and, you know, maybe those of us who have a couple of decades on that. But no, you're only, what, 16 years old?
Not that young.
So without telling us your actual age, let me flip over here. There we go. I will do a very brief introduction. I'm going to turn this over to you, and maybe you can talk a little bit about our topic of the day, and I'll interrupt you occasionally with questions. Watchers, if you are listening, you better be listening. This is really amazing, good stuff. If you got questions, post them on here. If Maxine can see them directly, she will answer directly, and if not, I will pull some out. And let me see who's here real quick. I didn't do that. Oh, we got a good turnout. Tolwood, of course, always here. Might catch a few minutes saying, okay, your car's done. And Patricia Grace is here. She's Patricia. It started for me mid-sentence. Okay. Everybody's doing good. I'm Jason Helms. Yes, time to get time change. Earlier things. Okay. I get upside down on that. I don't think that hard sometimes. It's 3 p.m. my time. So currently it'll go to 2. Okay. So it'll be earlier. Whatever. Just look up Central Daylight Time, 7 p.m. Wherever you are, that's what time it's going to be. History originated from early Christians who used to seek the protection of the Holy Cross, and it became widely adopted. Right. I was going to do that, but we don't have that much time. Yep, sad about the lander and starships. Space is hard. All right, everybody's here. And so, you are a student. What school do you go to?
I go to Stark State College.
Stark State, that's right. When I found that out, blew me away because I was born in the county where she goes to school. We're from the same town. We know some people from the same town, so we have a nice connection there. What are you studying, Maxine?
My major is cybersecurity and computer forensics.
Nice. Wow. I love computer forensics. I don't understand cybersec in the slightest. So that's awesome. You have your fingers. Fun. I'm sorry?
It's very fun.
Of course. You got your fingers in a lot of pies. I started seeing content from you 2 years ago, 3 years ago, in things that you were publishing and posting on LinkedIn. And we had another connection at that time. I was very active in CIQ and Rocky the company. I wasn't doing much as a contributor. You, on the other hand, are. So how'd you get interested and involved in Rocky, and what are you doing with them these days?
It's a very entertaining and fun story. So that was around the time when a certain big company was pulling some shenanigans around enterprise Linux. I'm sure many people are aware.
We have discussed it at great length here, and I have no problem saying their name in an abusive fashion.
Well, I guess I'm being a little nice about it. But around that time, one of the vice presidents said something about CentOS Stream being used to build Red Hat Enterprise Linux. And I put that to the test. I was like, can I actually use the CentOS Stream source code to build my own one-to-one Red Hat Enterprise Linux clone? He tells me, yeah, it's possible. So I spend however long, I think it was about a month or a few weeks, working on this clone all by hand. I didn't know about all the tools at the time. So it was very handcrafted.
Did you so how did you learn how to do it? I think is the way to ask that question.
How did I learn how to do it?
You learn the tools and learn where to get the source code and all that stuff. And it's not stuff that just pops in your head.
Well, it took some time. It's all it all blends together. There's no chronological timeline. It's all like a one thing at once or
Okay.
multiple things at once. So around that time, some key people from Rocky Linux saw what I was doing. Gregory Kurtzer, especially, he actually was the one to invite me to the project. And I communicated with some people like Skip Groob about what I was doing, and
that was the name I was trying to think of the other day. We've had both of those guys on the show here.
Yeah.
Back when they founded Rocky.
But Skip Groob taught me how to use some of the tools like Mock, and I'm very thankful for that. He's very kind.
Yeah,
So
if
when I
anybody
learned
would
how
know,
to,
and if anybody would be a great teacher, it would be Skip. He's a wonderful man.
for sure. So when I learned how to use Mock, I started building packages with Mock instead of doing it by hand on my computer, on my machine, like actual RPM building. And it was just this crazy conglomeration of building the system by hand and then figuring out where I need to get the source code. Like I didn't know where to get the source code at first. So over time, talking to people, I was told to look at the CentOS stream Koji. So I pulled packages, source code packages from the Koji, and then I was told I got to look at the GitLab. So I did that as well. I used Mock to, Mock can actually, has an interesting ability. It could pull directly from what they call an SCM, which would be like GitLab. So it pulls from the Git
Oh,
repositories.
that's nice. I didn't know that.
It's so convenient too.
And with yeah, so that's not the right acronym, but our new stream protector and provider, it's got to make life a lot easier for packages.
For sure.
Very good. Are you working on any particular projects with them right now, or?
With the Rocky people,
Yeah.
I do some community team stuff. I'm a volunteer for the community team, so I participate in event planning. I come up with little ideas for stuff we can do to engage with the community. That's a big part of what I do. Sometimes I pop into, like, for example, SIG Alt-Arch, and I offer like advice as well.
Awesome. I don't know if you've planned this far out, and I don't know if CIQ or Rocky has yet, but they were at Texas Linux Fest last year, and I just got my invite. It's in October. I had this fingers crossed attitude, but Linda, Krista was there last year, and we both had our fingers crossed that you would turn up, but if you did, it wasn't when I was there, but hope you're looking at it this year.
Unfortunately, I wasn't able to go. I probably won't be able to go again this year.
Oh, sorry.
Transportation's a little limited for me. At the moment, I can only go to Ohio Linux Fest, which is right up in Columbus,
right?
about an hour away.
Yeah, that just happened, yeah?
Yeah, that just happened.
Yeah, I know, because I got the notice about a week after. It's, oh man, I missed OLF again. It's a great show.
Well, I will be sure to keep you updated.
I appreciate that. All right, well, let's dive into what we're talking about here. You wrote a paper for school that turned out to be something far beyond a paper that you would expect for a class. It was a white paper. It was brilliant. It was technical. It was deep. For me, in the beginning, it was confusing. I had to read it and then go research, and then I read it again this morning, and it makes a lot more sense to me even now then. So I'm going to turn you loose. You can talk about the paper or talk about what Plan 9 is, where it came from, what's different about it than Unix, whatever you've got in mind. It's your show.
Well, first of all, I need to make sure I thank two important people. One of them is my professor, Steve Edgehouse. He made sure I wrote pretty well.
Professor.
And then another person is Andrew Gibson. He goes by Adventures in 9 on YouTube. I talked to him a lot about the IoT portion of my paper. And in fact, he gave me most of the information that's found in that paper, that part of the paper.
Thank you, Stephen. Andrew Gibson.
Andrew Gibson.
Yeah, thank you, Andrew. Okay. So what do you got?
Well, let's see. What do I want to talk about first? Well, IoT devices have been on my mind a lot because I used to never find IoT devices that interesting, but until I talked to Andrew Gibson, and he specializes in IoT devices, and he even ports Plan 9 to these small little single board computers to make different IoT devices. Actually, one of his coolest videos is where he gets the Philips Hue light bulb and he communicates with it on Plan 9. He wrote like a whole, what is called a file server. And that's a very interesting topic to go into. In Plan 9, the file servers are kind of confusing because there's the storing files file server, and then there's the type of file server where files are an API.
Okay. So let me
So
interrupt here. I'm sidetracking you for just a second here. The core philosophy of the Plan 9 operating system is that it's a distributed OS, right?
Yes.
So you've got file servers in the form that you're talking about, and then what's the other server type?
It's still called a file server, and they say that confusingly enough in one of their papers.
Okay. I'm thinking of the other one. The CPU servers.
Yes, the CPU server, yes. Thought we were still on file servers. Yes, there is the file server, and then there's the CPU server.
Okay.
And the CPU server is just a dedicated compute node. It doesn't really manage holding anything. It's just, you connect to this system and you basically take the CPU and you bring it onto your own system. You basically upgrade your system using CPU servers. You also get, when it comes to IoT devices, what I've seen Andrew Gibson do is he'll use the CPU server concept to make an IoT device an extension of the current system he's working on. So he can gather data.
Wow.
Like
what
CO2
an interesting
data.
concept. So for an IoT device like a light bulb, obviously that's got to be a pretty scaled down version of the OS, yeah?
The Philips Hue light bulbs, I don't know too much about. I know they're very simple. He communicates with their JSON API. He has this middleware that is I'm going to call it a file server, still confusingly enough.
Yeah.
He has this middleware that's a file server that communicates to its JSON API.
Okay.
But it makes the JSON API appear as files.
Right. Right. Everything looks like a file in Plan 9, right?
Yes, every single thing. Like everything. Even more so than UNIX.
Right.
Actually, a majority of Plan 9's system calls are just open read and write related calls. Just file system IO.
Yeah, I was looking at some of the C code for it and some of the shell programming, and it's both complicated and marvelously simple when it comes to communicating.
Isn't that really interesting? Like, it's both complicated and simple. I find that too. And I think what makes it complicated is it's a different way of thinking entirely.
Right.
And that's why it took me so many years to get a good understanding of how the architecture works and how specifically the 9P protocol works. It's because I had to shift my mind. I'm so used to like Linux and Unix-like systems.
Right. Yeah, it's a whole new ball game. So I've written in my own notes, while its roots are there, it has evolved into something well beyond what Unix ever became.
Writing my paper and talking to Andrew Gibson at the same time is what really like solidified my understanding.
Right.
And the way I understand it now is that Plan 9, the network is a computer.
Okay.
You don't just have like this single, what he referred to as like an island system, which would be like your desktop. That's an island system. It's very isolated to itself. In Plan 9, you would have a terminal, which is your access point, and it knows how to do terminal things, like take keyboard input and have a display. And then you would have your CPU server, which is dedicated to compute and running programs. And then you would have your storage server, that would store all of your files, do archival. In fact, if I remember correctly, Bell Labs had this like CD-ROM worm archival system,
Okay.
and they had that connected to their file server, and that would take like daily snapshots of the system.
So that's a really fascinating take on it because, of course, that was the architecture. Now, the dumb terminal and the smart mini computer or mainframe was kind of the original architecture that became commercialized and industrialized, and then Unix built on that, and now Plan 9 has taken it apart, I guess, and made some
Yes.
of those pieces mobile.
Yes, that's a perfect way to put it. It just split up the system in all these little modular fragments, and it's really cool. I also want to mention auth server, that would be a dedicated machine as well. So like all of these separate machines that work as one system. I believe in my paper I called Plan 9 a polyolithic time-sharing system rather than a monolithic time-sharing
You
system.
did, and I read that, and that was when my head exploded, and I said, I'm going to have to learn a lot more to understand this paper. Polyolithic is a great term.
I think that's the first time it's ever been used in relation to computer science. It's always just been monolithic.
Sure.
And
Nice.
polyolithic really just means many stones, like monolithic means like one stone.
Right. All right. Let me see, I'm rolling down notes here. Things we talked about. Where'd you go? There we go. That's not.
Oh my gosh, it's 8:30 already. I feel like we haven't even scratched the surface.
We haven't, and I knew that going in. So, but I want you to talk about the things that you find the most interesting at this point.
Well,
Okay,
I do
so you
want
got
to
interested
mention,
in IoT and how it applies to Plan 9. And
Yes.
you worked with Andrew on that. And where have you gone from there? Or are you still working it?
well, I'm still working at doing more research into it. I do have a few ideas. One of them I had a little while back was, IPMI, right?
Mm-hmm.
And that's basically its own little system. It's like an IoT device, pretty much. It's an
Sure.
IoT device for managing a computer. So I had this thought a while back, like, well, since they're just like a regular old IoT device, they have to serve their own web page. They have to handle maybe their own authentication if they have it. What if we just, instead of whatever they put on that, which would likely be a very stripped down Linux, put Plan 9 on there and have it communicate with an auth server that is just dedicated to authentication,
Okay.
and have it communicate with a file server for it to get utilities, or another file server that provides like API, maybe even a CPU server if it really needs it.
That would
But the
be.
authentication part is the most interesting to me, because I thought about it, well, maybe have a whole fleet of systems, or there's the central authentication server where people have user accounts on these little servers that they manage remotely.
The second you said it, it started laying it out. I worked in a knock last year, and we've got hundreds of racked up servers. Most of them are Supermicros running IPLI. But yeah, if we just took one or two dedicated servers, make an auth server, and make the CPU server / storage, and do it all in one server, maybe do it in VMs, you could handle the whole IPMI process as a single process instead of
Yes.
independently implemented on all of these hundreds of servers, thousands potentially. So what an interesting idea.
I'm thinking there could even be a way to make the whole fleet of servers look like one machine to manage to begin with.
Wow, and that takes me to a question that I made some notes on. And I think you've just answered it, but maybe you could expand on this. So it looks like if you took a fleet of servers and put them under the control is not the right word for this, but under the aegis of Plan 9, you've got a built-in high availability clustering system that should be very easy to manage and update. Am I mistaken on that?
No, you're not mistaken. You can definitely do that. Actually, in my paper, I did talk about Ansible, and at one point I mentioned it basically sweeps the certain problems under the rug, but Plan 9 wouldn't sweep those problems under the rug. It actually solves this problem of cluster management because the whole fleet of nodes could look like one system entirely.
Right. Wow, that's fascinating. And have you called Greg and said, hey, it's time to start Ascender thinking about Plan 9?
Greg is very familiar with Plan 9.
I'm sure.
He was one of the first people I talked to that actually knew what I was talking about when it came to Plan 9. If I remember correctly from our conversation, he used to work on XCPU, which was a cluster management like system. I've looked at it quite a few times and it's so interesting. There's even a paper I've read about it. And they actually, my memory might be bad here, but in the paper, I believe they communicated with different systems over RDMA. They were doing something with some PowerPC stuff, some weird architecture. And they had communication done over RDMA. And I believe, if I remember correctly, they found out 9P is the best protocol for that.
Wow.
Due to its simplicity.
Okay, well, let's talk about, you say 9P, and we had a little bit of a conversation the other day, and it was just to familiarize me with some of the terms that you were going to use, and I used 9P wrong. So it's not just shorthand for Plan 9. It is
No.
It's the heart of the Plan 9 OS, right?
Yes, it is the unifying protocol. It is like an RPC protocol, and that's what makes everything appear as a file system.
Okay, so
APIs,
let our audience know what an RPC is.
Remote procedure call.
Okay, and that means, good.
That's basically where you're calling a function over the network.
There you go.
Essentially as simple as that.
Yep, that's it. So if you guys are doing RDP, remote, thank you. RDP is not the one that I wanted there. The Microsoft RDP remote. And nonetheless, it all comes down to there is a process running in this computer. You want to take advantage of it from your computer. You can call that. And it gets called by port numbers. It can be as simplistic as that. It can be called by APIs, can be called by any number of methods. And this is the way early network computing was done. Everything was some kind of remote procedure call. And in fact, we were doing internal procedure calls, and then we tore them apart, put them on separate computers, and made RPCs, remote procedure calls. So P9 is the RPC heart of the Plan 9 operating system, right?
9P, yes.
9P, I'm sorry. And what is 9 front? I just read a little bit about that today, and I don't have a handle on that.
So 9 front is a continuation of the development efforts of Plan 9. I think they took over for Bell Labs, if I remember correctly. So they keep it updated with new drivers all the time. They create new software for it, and they even keep up on making the system secure. So there's actually, I learned that Plan 9 and 9 front, the authentication scheme is not compatible.
Really?
Yes, there's a vulnerability in the Plan 9 authentication scheme. I don't remember what it is, but I talked to Andrew Gibson about it. So they updated 9 front to fix that vulnerability, but in legacy Plan 9, it's still there.
Interesting. Okay, well, that makes a lot of sense to me now because I didn't read everything that I was supposed to today. But when we tie that up with the earlier research that I did, yes, you are exactly right. Bell Labs turned over development to, I'm going to get the name wrong on this, but something like 9 Front Foundation. And so they're like every other nonprofit development, maintainer organization, it sounds like.
The Plan 9 Foundation is who they turned it over to.
Okay.
So 9front was more unofficial. It was just by hobbyists. It was a continuation by them. Just simple, really. But I heard the Plan 9 Foundation actually made the Plan 9 source code MIT licensed. So it's not under this weird Lucent license anymore.
Right, because I was reading just about that today. So it was a Lucent license, and now we're MIT. That's really good news.
Oh, for sure.
It comes, besides digging into the tech specs this week and a lot today, I also dug into user spheres. Who's using it? What are they using it for? What questions are they asking? And I ran across a bunch of really interesting questions. That one you've already addressed very well. And that one too. They have a custom version of C according to a year-old user post that they say makes it difficult to port to other platforms. Can you speak to that?
Yes.
Okay.
Plan 9 uses its own dialect of C. It is a much simpler dialect. In fact, it's just completely different to the point where you either need to port the compiler itself to like UNIX or whatever platform, or GCC, for example, actually has a switch for Plan 9 code, like the Plan 9C dialect, because it's that different.
Wow.
But have you ever used Golang?
Yes.
Have you've written Go code?
A little bit. I've experimented with it. I've hello world it.
Well,
But
okay. Okay, well, if it's nothing much. But a fun fact about Golang is that initially they started out with the Plan 9C compiler. So if you use Golang a lot, you'll see some Plan 9C dialect in it. You'll see a lot of Plan 9C dialect in it because it's basically a port of the Plan 9C dialect in a modern fashion.
That's it. I just love how all these roots come together and fork back out. So that's slick. The native text editors saw a big long thread on discussion where some people took the take that they're all quirky and high learning curve, but once you get in, they're really good. And then one person jumped in and he said, Acme.
Yes, Acme really for sure.
And that one's not scary, and people pick that up pretty easily. So you seem to agree with that.
Acme is so awesome. It's very versatile. A lot of it can be scripted with just regular shell scripts by interacting with the file API that it provides. It provides its own file server for doing text editing, replacing text. I've seen people make a mail client with Acme.
Really?
Yeah, they've used Acme as a user interface. In fact, you know what Rio is, right? The Plan 9 window manager.
Yes.
You can even use Acme to replace Rio. Some people have done that.
I'll tell you what, I'm going to run a little slideshow here. You won't see it in our Zoom session, but you will see it on YouTube. Let's see, quick bump.
Also, I saw Patricia mention somebody was using Plan 9 in their co-read storage product.
Okay. Yeah, I'll let you read those messages. I'm going to go while I run through a little bit of slides here. We'll see if there's anything interesting. So here is what Maxine has been talking about a little bit. The architecture of this is made up of these file servers that are not storage servers, but they are processes. Everything looks and acts like a file, but these file servers may not actually be files per se. They can be a variety of devices. And then the magic of the thing, well, that's part of it, is these CPU servers. So as they add CPU servers, the system scales up in performance, right? Almost linearly.
I would say so, yeah.
Yeah, that's some of the performance charts that I saw said that file servers, that doesn't seem to be quite the same. It's good up until some threshold, and then when you extend beyond that threshold, performance drops off more slowly than it ramps up. But maybe this is a hardware limitation, maybe it's a backbone limitation. I don't know, but there seems to be some kind of fixed point where you can't have too many file servers, but you create another universe and you're off and running. So what did you call these? Islands, nodes, isolated? Down here at the bottom?
So I believe I called Plan 9 itself a polyolithic system, and we normally call all of these nodes as well, all these different computers, different nodes.
Okay. But they don't have to have their own intelligence. They're effectively dumb terminals, right?
Essentially, a lot of them can just be dumb machines. A lot of these machines can actually get their files from a file server. They can boot from a file server. Like they can either PXE boot, which I've seen that done. They PXE boot Plan 9, or they can have a very minimal Plan 9 system that uses a file server.
Okay.
And then if it needs to do anything compute intensive, it uses a CPU server as well.
Got it. So an IoT device would fit down here into this model, yeah?
Oh, yeah, definitely.
It almost goes without saying the way she said it. I get it. It's okay.
I've actually thought about really how to implement Plan 9 on IoT devices in like a commercial large scale setting.
Interesting.
And
I think you're probably thinking about thermostats. I get the feeling that you're thinking about industrial IoT.
Oh, not just industrial, even thermostats. All these devices matter. And I'm thinking like, well, it's probably still going to need to have a very minimal system on SPI flash, because a lot of them use SPI flash.
Right.
And the bare bones is a kernel with an init, what is essentially an init ramfs that knows how to boot using a file server. It just gets all its files from a file server, and then it gets all the utilities it needs. Doesn't really need to worry about how much storage space it has because the file server handles that. It doesn't need to worry about updating its own firmware because the file server handles most of that.
Sure.
Updating the kernel, it would probably be a little more manual.
Right. Well, it sounds like the tools exist for that if we clusterify them. And I wonder if you can take disparate devices and clusterify them in such a way that they look and act like a single system and could therefore handle an Ansible type single system patch, script, update, whatever.
Yeah,
but I'm just spitballing here. All right, let's take a look at this next slide. They call this a typical Plan 9 installation. This was from a paper written by a gent who I'll give credit to a little later on here, using Plan 9 as a basis for his paper and then went above and beyond. And I love this slide because it kind of made sense in a way that I didn't have in my head from everything that I read so far. We connect the high performance devices, the CPU servers, the file servers, the storage servers, with really high speed backbones. And then we only have to talk to our CPU servers and potentially our file servers with our dumber nodes with a slower interface like Ethernet. So maybe in the background I'm running 40 gigabit or higher, and down here I'm running gigabit Ethernet or maybe even fast Ethernet. Thoughts?
Yeah, this is exactly what the structure would be, okay. The architecture. 10 gig Ethernet. Basically, this just shows it all, really, that slide.
Okay. Yeah, I gravitated to this slide. It made so much sense.
Yeah,
this was just kind of in passing, as I mentioned at the beginning of the show, the first port to Raspberry and other ARM chips, therefore, was in 2012. That continues development from the F9 Foundation, so that's amazing and wonderful. And I don't expect to do this on Pi Day Friday next week, but before the month is out, there will be a Plan 9 running on at least 2 systems, and probably pull out 3. Let's just blow it up, right? You live in the real world. You live in the Intel and AMD world for everything you're doing, plus whatever's in IoT devices with which you're experimenting.
Yeah, I live in Intel and AMD world. I do need to get some more IoT devices to experiment with. I haven't really experimented with IoT devices in a while. The last time I experimented, I was working on this little IoT camera. I wasn't trying to put Plan 9 on it, but I learned a lot more about embedded Linux when I was trying to get my own software onto it.
Have you played with Home Assist?
I have not.
Okay, that may be a nice mesh. I've started messing with that just a little bit. A couple of friends of mine decided to go whole hog into Home Assist and use RPIs as their primary servers. They are, like myself, frankly, security paranoids. Okay, they hate the idea of a Google IoT device calling and saying, you know, Dave brings the temperature up to 71 on cold days at 3 p.m. And I know it's not supposed to remember Dave, but that kind of thing just tears my heart out. Home Assist doesn't collect and send to anybody. It just manages IoT devices. Or, yeah, okay, manages is right, but I would be curious to find out if there's a possible marriage there. I'll communicate that with you as I get further into the game.
I'll have to check it out.
Another slide that gravitated toward me, or I gravitated toward it. This is a screenshot of kind of sort of a desktop. And the reason I shot this one is just to let our watchers know that it still has UNIX roots, right? We still have the chmod command. We still use it in the same way. We make a script file or some kind of file executable and then launch it. This one's in a hidden directory. It's a graphics fetch program, I think, gfetch. But it had so much familiarity with.
This is the most Unixy I've seen Plan 9 look like.
Really?
I swear, I've never seen a screenshot like this before. I've seen people rice their stuff, but
yeah,
this is the most Unixy I've ever seen it.
I'll send you a copy. Let's see, we're almost done here. There's 2 more slides that I've got. Have we seen this desktop?
Yeah, plenty of times. That's the classic screenshot.
Yep, that's their normal screenshot. So it's a windowed operating system, or the GUI is windowed. Obviously, it's only operational in Germany from the upper left-hand side. Come on, that's a joke. But
do you know that you see the color scheme?
Yes.
Do you know that it's all pastel colors and that they specifically chose those because they figured out it's easier on the eyes and it's calming?
I did not know
Helps you
that. I
focus
realized
better.
it was pastel, but I didn't realize that was a conscious effort. I thought just whoever set this particular screen up said, I'm going to make it pretty in pastel.
Nope, that's the way that it comes as well.
That's cool.
They specifically made it pastel.
Oh, I cannot wait to get this thing fired up. So this was the performance charts that I saw. Let me get this gent's name and give him all the credit that he is due. These shots are from a paper by Jason Hickey back in 2004, actually, so these are pretty old. In MIT, the name of the paper was Providing Asynchronous File I.O. for the Plan 9 Operating System. And it was part of his degree project. Copyrighted.
Who'd you say it was again?
MIT. I'm sorry, Jason Hickey.
Jason Hickey. I might have heard that.
H-I-C-K-E-Y. Probably a name worth looking up. Maybe he's got some insights. So what we see here in this particular slide is as the number of servers increase, there is a little bit of increase in file I.O. And you can see they've got like 9 kinds of file I.O. activities going on here. No decrease, not a significant increase, but that's awesome, right? So as we add file servers, we don't lose any performance. We don't necessarily gain much, but the fact that we don't lose is a winner. So if you start with a high performance system, you stay high performance. And then the last slide, oh, I didn't do that slide that he did about.
I need to make a comment. I'm checking out this paper. I just found it online.
Okay.
It is so interesting.
Isn't
They're
it?
talking about avoiding tag collisions, big collisions, quick collisions. And those are things I've thought about. I've never found a paper on it, but those are things I thought about. I even discussed it with somebody at OLF, like the birthday problem or whatever.
Nice. Well, good. I'm glad I found something you can use. And then this is the last slide I have. We'll go back on cam here in a moment. We got about 5 minutes of show left. Plan 9 distributed operating system is a distributed system, gives users single system image of the entire network system. Man, there's so much I wanted to talk about here. I had questions. Based on what I learned today, I really wanted to dive into your paper. And there are people out there who actually, you may already know this, but they are publishing their thoughts or posting their thoughts on your paper.
Really?
I saw one. I'll find it for you, and I'll shoot you a link. Somebody was disputing your premise that about the networkability of it all, and saying, you know what, Unix is now and Linux is now super networked, and it fits well within that networked environment. So, without totally disagreeing with your premise, they had some argument points.
I want to see that so bad. I want to see what they said.
It never dawned on me, I assume. So I will. I'm swamped for the next 2 days, but early next week I will find that for you and get it shot out. Awesome. Well, I'll tell you what. I'm going to give you a couple of minutes of closing thoughts. Plan 9 is really good. People should use it. Plan 9 is not good. It's not for people. It's for, what do you got?
Well, I really want to focus on IoT in this part.
Okay.
IoT devices are using the wrong operating system. They're using a very centralized island system that is like trying to cook a pizza in a toaster. That's what I've compared it to.
It's true.
I mean, sure, it might be possible. Like you could make a little personal pan pizza. I was talking to my mom about that earlier.
Yeah, but that's shoehorning a solution. So
yeah, it doesn't work very well. It might be messy, which a lot of IoT device software is. It's very messy. It's riddled with vulnerabilities. And sometimes there's like no security at all on them.
Absolutely true. That's the first topic that comes up when we open up a consortium discussion on IoT devices. Where's the security?
And Plan 9 allows these little systems to borrow components from other computers. Like, hey, I need a more powerful CPU to do like some encryption thing, or I need to authenticate, I'll go to you, and then I need to grab my firmware and all my utilities. So I go to this file server and I mount it, and then there's all my utilities. Auto updating, what's that? The manufacturer's server handles it for me. And a lot of IoT devices don't even auto update. They require manual updating.
Isn't that amazing? How is that possible? They had this natural connection to home. They're going to collect our data. They could at least send them an occasional firmware update or a patch, huh?
Yeah, they could at least have a utility to apply it automatically, but a lot of times they don't.
Yeah, you've got the tool is there, FWUDP. Yeah, UPD, the firmware update within the Linux sphere, and they're adding features to that every day. I've seen IoT devices to it, but wouldn't that be cool if that was native? And you and I used the word bespoke the other day.
Yes,
native and bespoke within each kind of IoT device, make and model, and it wouldn't be that big of a deal since it's so stripped down.
But even then, I think IoT devices should just use Plan 9 and then figure out how to work with that operating system, because it's very hackable. It's very small and hackable. It's perfect for IoT devices, especially right now.
If I can hang on to you for about 2 minutes, I'm going to do the shutdown and shut everybody off here. I'll talk with you for a couple of minutes on Zoom when we get done with this, and then I will turn you loose if that's all right. Awesome. So everybody, many thanks to Maxine Hayes. What an amazing woman, huh? Watch her career. You're going to say, I knew her, I saw her when she was a student and she was just starting to talk about Plan 9, and one day when you see she's the keynote speaker at Black Hat, and how Plan 9 was used to secure the insecurities of the network under the direction of Dr. Hayes, do not be surprised. I'm not going to be. And so, everybody, we're going to get together next Friday for Pi Day Friday. We used to have a show, Maxine actually called Pi Day Friday. So we're going to do another Pi Day Friday. And in the meantime, you guys know the drill. I wish you a great rest of the week. Oops, got to do that. Yeah, okay, there we go. Take care of each other. Take serious steps to stay healthy, and if at all possible, please try to call or visit your parents. And never forget, technology is great, but the greatest resource we have are you and I. And with that, I bid you good night. I'll see you on ADRAMADA next Friday and on the other platforms I'm on. Until then, remember, how you do anything is how you do everything. Eep, op, ork, ah, ah.